We're still a bit short. Is there, can anybody confirm that time is either correct or fast?
That would be correct.
It is correct. Okay.
Well,
Mark?
5 minutes.
5 minutes slow? Okay. Welcome to Physics 152. The vast majority of you guys took this course, or took Physics 151 last semester. How many of the rest of you have taken Physics 151 here? Okay. How many of you took the equivalent of Physics 151 somewhere else? Anybody do that? Okay. So this course is basically the second version of a two-course sequence. The ones of you that have taken Physics 151 last semester with me, you're not going to notice any real big change. The course is going to be pretty much the same format, but a little bit of different content. Also a little bit more mathematical. The problems are going to get a little bit harder this time around. But there are a few changes for people who may have had Physics 151 or 154, well, Physics 151 or Physics 191 before. And I wanted to go over those. This will be a little bit of review for people who took the course last semester. But a couple of things. One, this will affect everybody. We are going to try to record the lectures and put them online again. We tried doing that a little bit at the beginning of last semester, but we had some technical issues. Basically, my computer ran out of memory. We think we've got those fixed. So I want to make the content available online so that if you missed something in lecture, you can go back and catch it after class. However, that does not mean that you should watch all of the content online, because a lot of the stuff we're going to cover, I'll talk about this in a moment, but we're going to be doing more problems, and for that I'm going to turn off the camera just because I'm not going to be up here talking, not any new information, it's just giving you guys practice. So you want to show up always, even though we are going to be putting the videos online. For people who took this course, who did not take this course with me last term, we changed the topic order around a little bit, and that might be difficult for some of you because we went out of order. So traditionally, physics courses, you have a two-course sequence. You do motion and Newton's laws and energy and momentum, and for the most part, that's what you have time to do in the first semester. We move things around because most of you guys are biology majors or exercise science majors or chemistry majors. So we put the things that were more relevant to you in the first term. For that reason, some of the stuff that was in the first term is now getting shifted to the second term. So we're going to do some two-dimensional motion problems. We're going to revisit courses. A lot of the things you guys had a hard time with the first term, we're going to revisit those. And so to get more practice with them, you'll learn very good by the end of the course. For those who have never had a course with me, why don't I go through the syllabus and we can get into that. Okay, so for people who don't know me, I usually just go by Santos. You can put the professor in front if you want, if you don't have to. My office is upstairs, just on the left of the stairwell. Usually, for office hours, let me just close this door quick. Usually for office hours, I will either be in my office or more likely I will be downstairs in lab just because there's more room, it's a bit more comfortable there. So if I'm not upstairs for my office hours, you can come see me down there. The office hours are listed on the syllabus. R is Thursday because that's kind of my quirky notation because Tuesday you can't put a T twice. So R is just Thursday. Actually, I'm wondering if there may be a few typos on this. In fact, there are already a couple that I've caught. when I was putting the dates down for the test, if you look down on the first page, I realized what I was doing is copying the year, not the date, which is why all of them are on the 15th. So the actual dates, the April one's actually correct, that happened to be on the 15th. But the actual tests are going to be on February 9th, March 6th, and then April 15th. So just make a change on there. I will, I'm going to make the corrections to this and then post this online. Also, my office hours might change a little bit too, because we're still having some scheduling issues for some other classes. I will put the corrected version of this online. I'll try to make an announcement about that next class. Let's see. All right, so we're going to have, let's see, course description. So this course is going to cover two-dimensional mechanics, electricity and magnetism, circuits, and modern physics. For the most part, we're going to be sticking with this textbook, which you most likely all have from last semester. If you get an earlier edition of this textbook, because it is vastly cheaper, that's fine. You just have to worry about the making sure you do the right homework numbers. Other than that, the text is pretty much exactly the same. It's just that textbook companies are kind of evil, and they come out with new editions so that you can pay more money. Let's see, what else do I got here? Course policies. Homework is due during class on the date assigned. For the most part, I don't give exceptions unless you talk to me ahead of time. So if you come to me the day before and say, hey, I have a track meet or a swim meet or some event, some legitimate reason why you can't be at class that day, I'm happy to give you an extension on the homework. But you do have to do that beforehand. If you do it afterwards, the homework will get recorded as a 0. Every week, I do 15-minute homework quizzes. So usually homework will be due on a Wednesday. But there are some times this week, this spring semester gets a little bit screwy because there are weird days when we don't have class, like campus day and a few other times. So the schedule gets moved around a little bit. But for the most part, homework is going to be due on Wednesdays. And usually the Tuesday class, if you look in the syllabus, most of the Tuesday classes are listed as problem sessions. So normally on a Tuesday, we'll come in, I'll have you guys ask me questions on the homework. Those days are really just an extra day to make sure everybody has some time to come in and ask questions that they might have gotten confused about on the week's assignment. Like I said, that won't be every week, because again, just scheduling wise, sometimes there's a day when, a Tuesday when you can't quite make it, because there's some campus event going on.
So will quizzes be on the days that problem sets are due?
Quizzes will be on the days that problem sets are due. Yeah. Any other questions so far? Other things. Let's see, makeup exams. You can take a makeup exam, but generally that'll cost you 20%. One thing I do, which is a little bit different than most professors, is so I don't like the idea of giving reading quizzes, because physics is really hard and you're not necessarily going to understand the reading even if you did all the reading. So for those who have not had me before, what I do instead is you do the reading and then you have to email me one question about the reading. Or, well, I should say at least one question. If you have more, you're more than welcome to email me more than one question. But it's the easiest 5 points you'll ever get. Basically, you do the reading, you just ask me something that you were either confused about in the reading, or if everything was completely clear, then just ask me something you're curious about from the reading. But generally, that'll be due once per class. If you look at the schedule, so obviously no reading for today since today's the first day of class. But for tomorrow, we'll be reading night sections 1.5 and 1.6. So you're just going to read those two subsections, and then before that class, you'll send me an email preferably the night before, that way I get a chance to read them, and then that way I know it was confusing, and we can go over that the next day.
Right, so you like, so if you want the questions tonight?
Yes, so if you, what you can do is just, they're pretty short sections, so you'll read section 1.5 and 1.6, send me an email before midnight, just, could be a one-line question, I didn't understand this part of what vectors do. Or if that's not a question. Better if you actually phrase it like a question. Saying I didn't understand something is not. If you formulate it like a question, I'll know better how to answer it. Yeah, I think that's it, mostly it for scheduling stuff. So we did reading questions, talked about the change in the topic order. One thing I would like to do differently in this course, and I don't know how much we'll be able to get to it, simply because there's a lot of material we have to cover. But I think the best way to learn this stuff is to do more problems. So what I'd like to do is, rather than have me come up in front of you guys and blab for an hour straight, I want to reduce that, maybe talk for 20 to 30 minutes, and then jump into basically have you guys work in groups, and then I can go around and answer questions for you guys. I'll have you work on a few problems, either out of the book or maybe it'll be something that I come up with. But that way it'll give you more practice. It should make the homeworks go a bit easier, and we can do some conceptual questions as well. That way the stuff on the test will hopefully go a lot easier. The more problems you do, the more you start to see the patterns in answering physics questions. And that should that'll hopefully make the tests go a lot easier. And we're going to, if we have time at the end, I'm hoping to start that a bit today. All right, I think that's all I have. Any questions about syllabus stuff?
So like, why are sig fig review, why is that highlighted?
That's highlighted. So the thing in gray, by the way, this will be, this is not online yet. It'll be online by the end of the day. But it's highlighted because that's going to be the lab for the week.
Oh, highlighting is labs.
Highlight, so the fourth one in each section is the lab for that week. Or what we'll be doing during the lab session. So this week it'll be, it should be pretty short. I just kind of want to review significant figures for people, because I want to make sure that there's a lot of points that got taken off last term with that, and I just want to review that so that that's not going to hurt anybody's brain history. Okay, more questions? Like I said, I'm probably gonna have to change the office hours around, and I will also fix the test dates on here. So that should all be corrected by the time you guys show up next time. All right, getting into actual physics stuff.
Oh, I have a question.
Yes.
So, what's this one? Is this the homework that you want us to do?
Nope, we're gonna get into that. That's gonna be problems we're gonna work on today.
Okay.
The homework will be posted online. I'll send an email about that as soon as it's up. All right, so last semester, we talked about motion. And one of the first things we did is we made motion diagrams. Way back 6 months prior to that. And we said if I make a graph and I label different positions for an object, it's -3, it's -2, -1, 0, 1, 2, 3, 4. I can label where a particle is on that graph. I can say maybe the particle's here at time 0, here at time 1, here at time 2, space, here at time 3, and here at time 4. Basically, just drawing a dot wherever the object I'm interested in happens to be at that particular time. I could also record this data in the form of a data table. I could measure my position in meters. I could measure my time in seconds. What values of time would I put down in this table for that motion diagram?
0 through 4.
Just 0 through 4. So 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. What would my position be for 0 seconds? -1 meter. That's -1. And I go to 1 second, I'm at 0 meters. 2 seconds, I'm at 1 meter. Or we could just put the same exact information in a data table. And equivalently, I could do one more thing. What was the other thing we did for motion to analyze, to look at it in another convenient form? I think you guys, it was probably the hardest part of the motion stuff before.
The position graphs.
The position graph. So I could just make a graph of the data. Instead, if I plot position versus time, all I'm doing is I'm looking at these coordinates and I'm just putting them on the graph. So at 0 seconds, I would be at -1 meter. There. And at 1 second, I would be at 0 meters. 2 seconds, 1 meter. 3 seconds, 2 meters. 4 seconds, I would get 3 meters. And basically just get a nice straight line. At least for that data, you get a straight line. So that's all very well and good, but now we want to do the exact same thing in 2 dimensions or 3 dimensions. So for 2-dimensional motion, it's really not that different. The only thing is I have to put in extra dimension. So for example, let me take the same x-axis that I had before. So let's say the particle starts at -1, and then it ends up at x equals 3. But now I also want to put in a y-axis. So y equals 1, y equals 2, y equals 3. So let's say the particle starts at x is -1, but at y is 0. And then later, it's at this point. And then at 1 second, it's at this point. So this is t equals 0. This t equals 1. This t equals 2. T equals 3. Let's say we're over here. And then let's say we're back down over here. T equals 4. I get something that looks roughly like a parabola. Well, all I've really done is just move some of my data points up. So if that's the case, my motion diagram is not all that different. All I need to do to go beyond the motion diagram, let's say I want to get my data table now, well, now I just need an extra column in my data table. So what would change in the time column? Nothing, right? I went from time 0 to time 4, from time 0 to time 4 in my one-dimensional case, and time is still going to be the same, still in seconds. Put my units in here. What changes in the x direction? Again, nothing. I started at -1, and I increased by 1 meter every second. So this is an important thing that's kind of subtle, is that the y direction doesn't change doesn't affect the x direction at all. They're completely independent. So I'm still going to get -1, 0, 1, 2, and 3 meters for the x direction. What am I going to put down for the y variable now? So what would y be if t equals 0? 0. That's all we're doing. That's literally all there is to motion in 2 dimensions, is you put one more coordinate in. We could also graph that. So we did our motion diagram, we've got our data table. Let's just make a graph of the y position as a function. I will use this notation every once in a while. It just means that y depends on time. Y is a function of time. The parentheses do not mean multiplied by time. In this case, I'm really writing a function. So we're going to say y is a function of time. 0, 1, 2, 3, 4. 3. And let's see. All right, well, where's my first data point going to be? It's going to be, say again? 0, 0. So I go over here. I look, well, my y is going to be 0. My time is going to be 0. So at t equals 0, I make y 0. At t equals 1, y equals 2. So I'll go over 1, 2. T equals 2, y equals 3. Equals 3, y equals 2. I'll put those 2 in. 2, 3. 3 up 2. And then the last one, over 4 up to 0. 4, 0. What do you notice about the shape of this curve? It's the exact same shape as the trajectory that we had originally. So yeah, it's the same thing. Now let's actually make that motion. There we go. We have the motion. Projectiles tend to make this parabolic shape. In this case, since x is going up by 1 every time, and time is going up by 1 every time, it's like x and time are directly proportional. These two are just proportional to each other. So it doesn't matter whether I plot x or t on the axis, I'm still going to get something that just looks like a parabola. I'll get the same shape, because those two variables are proportional to each other. Let me stop there and take questions really quick. Anything so far? Easy stuff so far? Okay. In that case, we're going to bring things up a little bit. So as I mentioned before, the order of this course is a little bit different. People who took it with me before have not seen vectors yet. People who have, this will be a little bit of a review for you. But reviews are good to have. Okay. So we want a way of describing this two-dimensional motion. And the way to do that is with a vector. So let's say I'm interested in this vector. A little bit. Say I'm over, not the height 3. So let's say I'm going back to my projectile picture. And here's my motion diagram. Let's say I'm interested in where the ball is at that point. I can use a vector to describe where that ball is. So if you were going to tell me how to get to that point, what would your instructions be? Where is that point? It's going to be, oh, you'd say, I should really put units in here. You'd say it's over 3 meters, or up 3 meters and over 1 meter. So go over 1 meter, go up 3 meters, and you'll be at your point. So we could say that a vector is really, it's not just a number anymore like we had in one dimension. It's really a collection of numbers. In this case, the numbers would be the 1 that you move over, and then the 3 that you have to move up. So it's a collection of numbers. Another way to think about this in the physics sense is we could say it's a magnitude and a direction. And I will talk a little bit about what I mean by those two terms in just a moment. But let's just stick with a collection of numbers for right now. So you want to write your position. I'm going to give my position the symbol R. And notice I put an arrow on top of the R. The arrow means vector. That means I need to either give you a collection of numbers, or I need to give you a magnitude and a direction. I need to tell you how far you're going to go and in what direction to travel. Now there's a few different ways to write vectors. In class I am probably going to stick with this one because that's the one I like the most. I would say you go over 1, here you went over 1 meter, and then you go up 3. So I'll write it this way in angle brackets. Right. The first one is how far you go in the x direction. The second number is how far you go in the y direction. That's easy enough. These numbers have a word when I put them in this form. These are called the components of the vector. Now, if that's all that physicists use, life would be great and dandy. Unfortunately, physicists can't agree on notations. So you will see a lot of different notations that mean basically the same thing. So another way of writing this is like this. I believe this is the notation that Lent uses in the book. Notice these guys have a little funny hat on them. It is actually called a hat. And the hat, the y hat, is basically, it's kind of like its own vector. In fact, it's called a unit vector. And all this vector does, its length is 1, but it tells me that it's pointing in the y direction. So what this means, so let's say I look at this thing, I would say that as in the x direction. That's how I would pronounce the x hat. So I look at this and I would say, if I were giving you instructions on where that point was, I would say it's 1 in the x direction, and then plus 3 in the y direction. We're starting to know each other so well, we can finish each other as sandwiches. Is that Scrubs? Okay, so that's another notation that's pretty common. Maybe it shows up on the MCAT or the pre-dental exam or whatever you're going to see. There's one more notation that's pretty common. So a lot of times you write the x, y, and z directions as x hat, y hat, and z hat. Sometimes physicists don't like x, y, and z for whatever reason, so they use I, J, and K instead. So sometimes you will see this. It means the same, it means exactly the same thing. The J direction just means the Y direction. The I direction just means the X direction. But it is a notation that's pretty common, and if you happen to see it on a standardized exam, then I want to make sure you know what that means. Any questions about notation stuff? Okay, in that case, let's go back to this vector. So this is 1 in the x direction and then 3 in the y direction. And as we said, it's just a collection of numbers. I've got my 1 and my 3 that tells me how far I have to go. But that's not the only way I could specify this, right? I could also tell you, if we were standing next to each other and I was trying to give you directions to the supermarket or the Kent Center, I could say, go blah blah distance that way. That way is a perfectly acceptable way of specifying the directions to a point. And so we want to be able to mathematically write down a way that basically means that way. So the two things we need to do is we need to say, all right, well, how long is this vector? What's its length? Because I need two things. I need to say what the direction is and how far I go. So I will ask you, how long is that vector? How would I find the length of that vector? It's going to be the magnitude, and I use what theorem I heard somebody, I think, say? Pythagorean theorem. So if I want to write the length of this vector, there's a few ways I could write it. I could write it as r without the arrow on top. That just means the length of the vector r. Sometimes you also see this, r with the vector on top, but you take the absolute magnitude. Well, you use the symbol absolute magnitude. That just means, just give me the length of it, I don't care what direction it's in. And if I want this, if I want the size of it, I can figure it out using the Pythagorean theorem, because the Pythagorean theorem says that r squared, well, a squared plus b squared equals c squared, which in this case we'll write as r squared is x squared plus y squared. And we can write that as solving for r is going to be the square root of x squared plus y squared. So this is an important one to remember. What's that? But that by itself doesn't tell me how to get to that point. If you, let's say I told you, well, the answers to the first test are written up and buried. I was going to do pirate treasure, but I feel like test answers are more relevant for the course. The answers to the first test I wrote up and I buried, and I'll let you go get them. Just go 100 meters. So you're going to dig 100 meters away. What's the problem with that? I don't know which direction. So basically you're going to end up digging a circle 100 meters in radius, which is a lot of digging. Really what you want to do is you want to say, all right, well, if I could tell you what angle to go at, or maybe I could tell you it's 100 meters north, or 100 meters northeast or east. If I specify the angle, then I can tell you then you could know exactly where to start digging. So you use Pythagorean theorem to figure out the r. What do you use to figure out the angle? You're going to use SOH-CAH-TOA. So we know, I'm going to do this, I'm going to change this up a little bit just to make it more general. We're going to say that's x. We're going to say that's the y height. We were working with x and y before. I'm going to use SOH-CAH-TOA. I know what the x and the y are. So what type of side is y compared to that angle theta? It's going to be the opposite in this case. X would have to be the adjacent. So if I know the opposite and adjacent sides, which part of the SOH, the CAH, and the TOA do I want to use? Should be, so I know I don't have the hypotenuse, so I can't use the SOH or the CAH. I've got to use the TOA, which means that the tangent of theta is just going to be 1 over right over x. Right, you filled your quarter for the day, so I'm going to have you. I gotta hear different voices all the time, or I get bored. Gotta make sure this is a more even discussion. All right, so what I can do is I can solve this for theta, make the inverse tangent and get theta. And this gives me the direction. So this gives me the distance to the point, the distance or magnitude. And that gives me the direction. So I can go from the collection of numbers, the components of the vector, to the magnitude and the direction. I can tell you, if you give me x and y, I can figure out how long the vector is, and I can tell you what direction it's pointing. We also want to be able to go the other way. There's really 4 equations you need to do everything we're going to do in this course with vectors. Sometimes we're going to go from x and y to r and theta. Sometimes we're going to go from r and theta to x and y. So let's say, do this drawing one time. Let's say, I know this distance is y, and that distance is x. Going the other way. I know what r is. I know this distance. I know what theta is. Let's say I want to find x and y. So how do we go the other way? Okay. How can I relate x to r, which is the hypotenuse, and theta? How can I relate x to r, which is the hypotenuse, and theta? It's going to be cosine, because what side is x? Yep. So again, I know that the adjacent side, the adjacent side over the hypotenuse is the cosine of theta, but the adjacent side is just x. It's the side that's close to the angle. The hypotenuse is the long side, that's just r. So what that means is that x is equal to r times the cosine of theta. It's just SOH-CAH-TOA and the Pythagorean theorem. It's really the only things you need to know for vectors. Let's say I do the same thing, but I look at the opposite side over the hypotenuse. What trig function would that be? Opposite over hypotenuse would be sine. That's the SOH-CAH-TOA. What's the opposite side to that angle theta? Because I want to know. Physics, dad jokes. Yeah, so the opposite side to the angle will be y. The hypotenuse is still r. And then I can solve this equation for y and just bring r over to the other side. And you get y is r times the sine of the angle. That's really, these 4 equations is really all you need to know for figuring out components and magnitudes and directions of vectors. Any questions on that? All right, so as I said before, the only way to really learn this stuff is just to do lots of problems, and rather than have me just keep talking to you guys, let's just jump in and do some problems. So that's why you have the photocopied sheet in front of you. And here's what I'd like you to try. I'll have you guys break up into groups. You can work together. I'll turn the camera off in just a sec. But I'll just have you go around, and I'll go around as you're working on these, and see if you can get through these problems. I'll write the numbers up here. Here in this room. Let's do 24. 20, 29. 32, 34. I'm going to jump around a little bit. What did I say? 28 and 37. We've got about 15 minutes. If you don't get through all of them, that's fine. You can try them at home, but try and see how they go. And when we finish up, like I said, I'll go around and you can check your answers with me. If you don't finish up, feel free to practice these more on your own. You guys are already working.
So,
What's that?
so with the